Hi everybody, my name's Pete Cook, and what I'm going to do today is to solve the biggest problem in science, the biggest mystery. And I'm going to give you evidence that you can go away and check, and it's all testable by experiment. The trouble is that modern science is so big and so complex, it's just spread out all over the place, and the vital clues need to be picked from all the parts and laid side by side. So that's what we're going to do. And what do you think the biggest mystery in science is? The mystery about what dark matter is? No. The biggest mystery in science is when you look out the window, the matter is not just the rocks and the water. The same matter has changed into living things. Now you might think, by listening to Brian Cox, that we've got that pretty much sorted. Well, we haven't. And it's a much bigger problem than anybody suspects. This is the problem. I'm going to lay it out for you. Here's physics. I've got two different kinds of physics. The small physics, particles and atoms. Big physics, gravity. And I cannot get from here, this matter, to this matter, using the physics. It's the same matter. Your body is made of exactly the same elements which sit in a periodic table, and there's no more physics from this book which can do anything more than just stick those elements together. That's it. Now that's a huge problem, and people don't talk about it like that. And in fact, you can't even get from this physics to the simplest of molecules. Now that's going to be a big shock to you. You can check it out. Molecules, when they stick together according to the rules of group mathematics. That's not in here. That's not physics. That's matter obeying the rules of pure mathematics. That's always been a mystery. So let's see what some very good scientists have to say about that. One of the great enduring mysteries is why mathematics seems to mirror so perfectly what goes on in the real world. The physicist Eugene Wigner puzzled over this in an essay, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Why indeed should particles obediently line up according to the rules of group theory? Well, group theory is not physics. So that's a problem at the atomic scale. I can't even explain the simplest of molecules using physics. And it's not just a problem at the atomic scale. I've got exactly the same problem at the gravitational scale. The physics of gravity can only explain, at most, the motion of two bodies in space. Now that's the best kept secret in science, because it's embarrassing. It means that the solar system can't go in this physics book, and that's a real shock to physics students at university. And they look in the book and it's not there. There's a very good reason it's not there. That Newton found out the reason that physics stops at two bodies. If you have three bodies in space, they must be of equal size, so they can all pull on each other. Their behaviour is completely chaotic. Now that doesn't work with something like Mars and two tiny moons, because the tiny moons don't affect Mars, or the planets don't affect the Sun enough to feed back that movement into the whole system. But three bodies in space is chaotic. Now that's a contradiction with physics, because physics by definition is deterministic, predictable. Chaos, by definition, is unpredictable. So I've got some rules here which are predictable, but they don't even explain a simple molecule, never mind a virus, the workings of a cell. It's the same elements inside the cell, there's nothing else, and there's no more rules in there. So that's a big problem. At both physics scales, we cannot explain the reality that we observe. It's too complex. It's self-organizing. It has unpredictable parts, chaos and turbulence. Now, it's not that we don't have an account, a very good account, of chaotic behavior and the self-organization of systems in nature. So what's the problem? The problem is this. This is the best book that's been written on nonlinear dynamics. Chaos and Nonlinear Dynamics by Robert C. Hilborn. Now this describes the motion of chaotic behavior. So what's the problem? Why can't I just put these two together? Let me read the problem to you. He states it. There's a tradition in the West that one day physics would answer all these questions. It would be able to explain all the behaviour of matter. The LHC, Large Hadron Collider, would come up with some new forces, a new way in which particles could talk to each other. But that hasn't happened. And the French mathematician Poincaré, he wrote a proof that there are no equations in physics that can answer the three-body problem. None. Mathematical proofs are absolute. So that's it. Physics is never going to answer that problem. So let me just show you what the problem is. In a traditional physics setting, if we see some common quantitative and qualitative features in the behaviour of different systems, we look for some common underlying physical cause. So that's it. The first physics we do seems to have a cause. Gravity or magnetism. There's a force making the matter do something. A physical, underlying physical cause. And we thought everything was going to be like that. But then comes quantum mechanics, the physics of atoms, where an electron has to be here, or here, or here. And there's no physical cause, it's just a mathematical rule. So there seems to be a separation of physics into physics, classical physics, magnetic fields, gravitational fields, which have forces and physical cause. Quantum physics for atoms, which doesn't. And then this behaviour, chaotic behaviour, and complexity, the self-organisation of matter. Now you might think that when you try to put some numbers on chaotic behaviour, you can't. And if you take the behaviour of a chaotic system at the individual event, it just seems like chaos. But if you use computers, you can iterate those events. You can put thousands of events into the computer and it will just keep turning out answers for you. And in the 1980s, something happened that nobody could ever have predicted. The physical behaviour of systems in nature, which are chaotic, started to show patterns. They all showed the same pattern. A pattern which is governed by the same two mathematical values. It didn't matter what the system was. It could be a living system. It could be a mechanical oscillator. It could be a laser. It made no difference what the physical structure or entities were. The same mathematical values governed the system. Now that was a shock, a real shock. But it means that it's testable. It's physics, it's physical components, and they're behaving to laws that you can go and test, and you can repeat the experiment, you get the same answer, so it's good science. But there's no physical causes. It's just matter behaving to the laws of mathematics, laws that we couldn't get at without computers. Now, let's just see what Robert C. Hilborn says about that. We should reflect on this agreement between theory and experiment. That's very, very important. All good science has to be backed up by experiment. It's good science. We should feel a sense of awe and wonder that there is some quantitative link between experimental results and a mathematical iterated map. The same mathematical map. Now I've got some of these maps to show you here. This is the behaviour of chaotic systems, something nobody had ever dreamt would occur. Something we couldn't have predicted. And this map produces the Mandelbrot Set. The Mandelbrot Set is a mathematical system, purely mathematical. Now nobody tells you that the Mandelbrot Set is describing the behaviour of natural systems, of matter, out there in the real world. They think it's just a mathematical plaything, but no, this is the behaviour of matter. So I've now got 4 fundamental behaviours of matter. I've got classical physics, which has forces, gravitational forces caused by fields. I've got quantum physics, where mathematics is just coming out of the atoms are using the mathematics to build themselves. It's just a mathematical rule. Then I've got chaos. Chaos turns out not to be just random behaviour. And then I've got the self-assembly of complex systems, the self-organisation of matter. So let's answer the problem. We've got 4 different kinds of behaviour, physical behaviour. We've been trying to squash them all into one. Traditional predictable physics. It hasn't worked. It's never worked since the time of Newton. So let's stop. It's never going to work. Instead of trying to put everything into here, why don't we say, well, if we know beyond doubt that matter behaves to purely mathematical rules, then those are the rules which the universe is using to build itself. Simple. And if I think about it, these are not underlying physical causes. There's nothing physical about space. Einstein taught us that gravity is not an attractive force. There's no action at a distance. Gravity distorts the mathematical medium of space and causes matter to move along geometric paths, which if they meet, things collide, but they're not attracting each other. They're following a mathematical rule. This physics is the same as quantum physics, chaos and complexity. And the same must be said for a magnetic field, an electrical field. There are no physical forces. There's only matter behaving to mathematical rules. And let's prove that to you. The mathematical shapes that you see in nature could not be there unless ordinary matter was using the mathematical rules that produce the shapes. That is the sentence that will define the rest of this century. And just to show you how much of a problem this has been causing us, here's some very, very good scientists getting it wrong. So, here's Brian Cox trying to explain that the sand in the desert never makes a sandcastle. That things always become more disordered. But that's not true. Everything that you can think of in the universe, after a neutron and a proton, everything makes itself from something simpler that went before. It's always becoming more complex. So the problem is, if you don't have all these mathematical rules, you've only got simple physics, you can't answer the question, and everything has to be happening by chance. He even says, and this is the bit that I really don't like, this is very bad science. If you start moving sand grains around at random, they are overwhelmingly more likely to form a shapeless pile of sand than a sandcastle. But we know atoms don't fall together randomly. They use the laws of group mathematics. And the solar system doesn't self-assemble randomly. It produces fractal patterns. A large body, lots of small harmonized body, and rings. Every gas giant. And the whole thing, the sun, the planets, all harmonized, and the asteroid belt, the sun's rings. It's a fractal pattern. So Brian, on that one, you're wrong. And that's one that I've never liked. And if you go to BBC, in our time, the second law of thermodynamics, you can hear the scientists giving shocking excuses of why the universe only goes from order to more disorder. It doesn't work. And Melvin Bragg complains bitterly. That's not right. It can't be right. Well, Brian Cox knows there's a problem, and he says there's something about entropy that we don't understand. And there is. But you can hear very good physicists standing up saying, oh, well, life can get more complex on the Earth because it's a closed system and you've got sunshine streaming into it. But that's not a description of how the elements change into living things. It's just saying that it can do. But the solar system doesn't have an external energy source. It is a closed system. And it just becomes more and more mathematical. So any of those arguments are nonsense. And if you're told them, you have to stand up and say, I'm sorry, that's nonsense, and there is an answer. So there's a perfectly logical answer of how we can describe the reality that we observe. And people are getting very, very close to it. It's not just me. Let's listen to what Marcus de Sautoy has to say in his book, What We Cannot Know. It's amazing to me how time and again the physical world seems to turn into a piece of mathematics. We have to ask ourselves, to what extent is this just a good story that helps tie the physical universe together, or is the physical universe actually a piece of physicalized mathematics? Yes, Marcus, it is. Because if I look under physicality, there's nothing physical about the units of energy that make the physical world. Fields, gravitational fields, have no physical presence, but they cause matter to move. Now, matter has positive and negative parts. Now, they are mathematical aspects of matter. And if matter doesn't come in two equal and opposite parts, I don't get positive volume between parts which attract and repel at the same time. The physical world doesn't emerge from the mathematical world. Think of light. It moves in a sine wave. That's a mathematical function, not a physical one. And I've got two parts. Each part makes the other. That's a universal principle. So here we have an answer. Matter obeys the laws of mathematics. It uses the rules as the software of the universe. And you can go and check that. You can check the experiments in chaos theory that matter obeys these mathematical rules. You can test everything that I've said today. Now this has been published, a beautiful article, and we've put a link under there. What is life? We now have a description of how matter changes from simple elements into molecules using mathematical rules, and then it becomes dynamic systems using more mathematical rules and more mathematical rules, and I keep putting more and more layers on until I get to animal behavior, which is just mathematical rules, and matter that you can see obeys those rules. So we have to stop using an idea from 1600s which has never worked and flip over into something which is logical, a logical description of reality. That's it. Now in the next video I'm going to show you some of the really interesting bits that have come out of this. That all of matter obeys the same periodic repeating pattern based upon prime numbers. That little pattern is at the base of physics, chemistry, biology, geometry, arithmetic, game theory, music, language, anything you can think of. Just one pattern. And this time Brian Cox gets it right. And he says, underneath everything in physics, there's a simplicity. And nowhere is that simplicity more obvious than the construction of the elements. So next video, I'm going to show you what that simplicity is. So thanks for watching, and watch out for the next video. Bye bye now.